Hello and welcome to this video on the configuration of the CC3D flight controller on your ZMR250. Now we're using LibrePilot here, and we'll provide a link in the comments below for you to download this. And we're going to go through the vehicle setup wizard for how to configure the CC3D. It's very simple. But before I do any of this, we of course need to connect the CC3D to the computer using the USB cable here. So in the guide we mounted the CC3D so that the USB port is very accessible, which is very useful. And you'll know that the CC3D has successfully connected to the computer because you'll see at the bottom here that these little lights here will be on, and so it'll be receiving information from the CC3D successfully. So before we go through the vehicle setup wizard here, we're just going to update the firmware on the CC3D, which is always a good idea to do, just to get the latest firmware so everything runs smoothly. So this is very simple. You just go to the firmware tab, which is at the bottom here, and then you just go to the top here, which just says upgrade, and it connects to the internet and downloads the latest version of the firmware. So the status is just here. And there we have it, the board was updated successfully, as it says here. Press OK to finish. Or just finish. So now, we go back to the Welcome tab, and we enter the Vehicle Setup Wizard. So the first page that pops up is a general warning about the propellers. So the reason that we haven't attached the propellers yet in our guide is because we need to leave them off for this configuration, just in case the motors decide to spin up and we don't want any cut fingers or anything like that. So make sure all the propellers are off, and we can continue. So this is a page about the firmware update, but since we've already done that on the firmware tab, we can ignore this step and we can just press next. And this, as it says at the top here, this is the board identification, and it should say at the bottom here all the correct information. So we're using the USB to connect it, and it is indeed the OpenPilot CC3D board. So that's all correct, so we can move on. So now this is the input signal configuration, and as you will know, we used one cable per channel for each of the receiver, and so this is a PWM signal, and so we choose that option there. So it's already selected, so that's great. So we press next, and then obviously this is a multi-rotor rather than any of these other options. So this page is just telling the CC3D board which configuration of quad we're actually using. And so you see from the drop-down menu there are several options for which multi-rotor you're using, but by default it is quadcopter X, which is in this configuration, which is indeed what we do have. As you can see, it's pretty much the same. Obviously it's not exactly an X, but it's an approximation. So that's on the right option, so we press next now. So this is telling the board which ESCs we're using, and the ESCs provided in the ZMR250 kit are Simon K ESCs, and so they support the rapid rate, which is selected by default. So that's great, so we press next. So this screen is about connecting your receiver correctly, as you see from the connection diagram here. But we've already done this, we've already taken you through how to do this correctly, so you can ignore this this page and just press next. And then this one is, if you read the paragraph, what it says here, is just to keep your ZMR250 as level as possible, put it on a level surface as possible, and then so the sensors can calibrate. So once it is as level as possible, which this table approximately is, you press calculate. And yeah, it's done, as it says in this bright green done here. So we press next. So this is the Esd Calibration Procedure, as it says there. And this is pretty simple. You just need to follow the instructions on the screen. But once again, please ensure that you remove all the propellers from the motors, because this is the stage where things could go wrong. But yeah, so it's best to remove the propellers. So we first need to, one, confirm all safety questions, which are these three just here. I've removed all propellers, yes. The vehicle is not powered by an external source, which will be the battery that we have on top there. But as you can see, it's not actually connected yet, so yes. I confirm I've read and understood the above instructions in full. Let's just go through them. So we'll be pressing start, the start button when it becomes enabled, with the battery not connected, and the start button becomes enabled when we've ticked this final box. We'll then connect the battery, and then wait for the ESC to beep. Press the stop button, wait for the confirmation beep, and then disconnect the battery. It seems fairly straightforward. So I tick this final safety question, and you can see the start button is enabled there. So we follow the other steps. So I press start, and then connect the battery. The ESC's beep, and then we press the stop. The ESC's beep once more, and then we disconnect. So now we enter the output calibration. And this is for the motors on our ZMR250. And this process is telling the CC3D flight controller at what signal value the motors start to spin, only start to spin. And this is quite similar to the process before where we calibrated the ESCs, because that provided the throttle range for the ESCs, and this is a pretty similar process. But let's just get started and things will get clearer. So there's nothing we need to do on this first screen, so we just press next. And now we start the process. Now, you can calibrate all the motor outputs at the same time by ticking this box, but for clarification and to go through things slowly, we're going to do it one by one. So, as we do it one by one, we can check the orientation of each motor first, I guess. And so the first one, which should be the top left motor, should spin in a clockwise orientation. And so to start this process, we first need to plug in the battery to power the motors. So that's powered. And now we press start at the bottom here, and then there's this tab that we can move across here, and the motor spins. And you notice it's just the top left motor, so i.e. motor 1. And to test the orientation, you just put your finger to it, and you see it pulls it around, so that is a clockwise orientation. And now we need to figure out the point at which the motor just starts to spin. So we need to change this signal value until the motor just starts to spin. This is quite delicate, and so it's a good idea to use your arrow keys on your keyboard here, so you can move it up and down one at a time. So we go down, and at that point it stops, so we just go up, and that's just starting, and so that's the perfect signal. And so we press stop, and we go on to next, go on to the next motor, and so this is the top right. So this motor should be spinning in the counterclockwise direction. So let's get going. Bring it back up again. And that's pulling my finger around to the left, so that is counterclockwise as needed. And again, we change the signal until it just starts to spin, and this should be the same as the previous motor, and it is 1116. And these should all be the same due to the previous step where we calibrated all the ESCs at the same time. So that's great. So we can stop that there and head off to the next motor, which is 3. Bottom right, and this should be going clockwise as the same as motor 1. So again, put it up, start, and then put it up. It's going clockwise, excellent. We put it down, see if it's the same as all the others. It is. 1116, that's perfect. Stop that. Move on to motor 4. test the orientation. It's going to counterclockwise as it should, perfect. And then we bring it down to its neutral point, which is 1116, as all the others. So that's great. If at this process you do find that the wrong motor is spinning, so you want motor 1 to spin instead motor 2 spins, then this tells you that you've connected them incorrectly to the CC3D board via the servo cables. So you just need to swap the two motors around that are moving incorrectly. On top of this, if you find that the orientation is incorrect, that means the ESC to motor wire is incorrect. So you just need to swap two wires and swap them around, and that should therefore correct the orientation. You can find more detail on how to do this in the guide. And then after we've done the process, we of course disconnect the battery to make things safe. So this is the initial tuning page where we tell the CC3D how to react to our stick movements on our radio control. And as it says at the top here, we basically find a model that fits closest to the one that we're using. Obviously this is the ZMR250. And so if you go down to the bottom, you see there's 3 variants for the ZMR250. And the one that's actually closest to the one that we are using is this middle one. And this is the case because this is a 3-cell battery and the motors are close to what we're using. But basically these other 2 are using 4-cell batteries, which would not be suitable for our setup. So the middle one's closest. This will do for now, but we will provide a PID file that you can upload, and that will be much better. But this will be fine for now. So that's done. So we press next, and that's the end of this setup wizard. So we press save to save all the configuration. And that's it for the CC3D, but now we move on to the setup of the transmitter, as it says here. So this little tab has just popped up, saying the arming settings are always set to always disarmed. Because we'll be playing around with the transmitter, we don't want the quadcopter starting up for any reason, so this is always a good safety option. And obviously at this point it is a good idea also to have the propellers still not attached, just in case something does happen and it flies up into your face. That one's very pleasant. Okay, so once you pressed OK, it takes you to this screen where we configure our transmitter. So it's just a welcome screen and just saying follow instructions, so we press next. Okay, so this screen is just letting us choose our transmitter type from Acro stuff. So helicopter, we're using the Acro one, which is just a normal transmitter for a quad. So we press next. It's choosing the mode, and almost everyone nowadays uses mode 2 with the throttle and rudder on the left and the elevator and ailerons on the right. And this is what we'll be using, so we press next. And then at this stage we need to connect the battery on our quad to power the receiver, the radio receiver, as you can see there. We then take our radio, turn this on. So we now just simply follow the instructions on screen. So remove the throttle stick, up and down. And then the instructions change to remove the roll stick, sideways. And then move the pitch stick, up and down. Move the yaw stick. And then we have toggle this switch for the flight mode. And then we can toggle this one for the accessory 0. And then that's it for us. We don't have accessory 1, 2 or 3, so we can just press next or skip for those 3. And then we make sure to center all these. For the toggles that only have 2 positions, either position's fine, but make sure this is centered and this is centered, which it is. And then press next. So at this stage you need to move all the controls to their maximum extent in both directions. So just take this around in circles, and down, sideways, click this a few times. So once this is done, you should see that the sticks on screen will move at the same position that you move the sticks in real life. You may have, as you can see here, one of the directions being reversed. So you see when I put this up, this stick up, it actually goes down, and vice versa. But you don't need to worry about this because this will be sorted out in the next step. See, accessory 0 is working. Flight mode is not working at this point, but this is because the CC3D board thinks that this is a 3-position switch when it's actually only 2-position. But we'll sort this out later in the configuration stage, so that's fine. So this then goes on to the arming settings. So it previously had it as always disarmed by default, and we have lots of different options here, but we like to always arm it with putting the yaw to the left. So that means to arm it, you just need to put this to the left, and then it should be armed. So that's that. Okay, so once you press save, we can actually check that this has saved the settings properly. So we want to test if it does in fact arm. So we move the yaw to the left.
Armed.
And you'll see it says armed. And so once we move the throttle up, the motors will indeed go. And then we disarm by doing the exact opposite, putting the yaw to the right. And it's no longer armed. Now you will have noticed the LEDs on the CC3D board changed when it was being armed and disarmed, and so that's a good indication that it's working. So once we've gone through the transmitter setup wizard, best go through the flight mode configuration. So we can go to the input tab here, which is just this one, and here we can test all the inputs. So if you move the throttle up, it's a bit delayed, but you see the throttle moves up there, and move it down, it moves down. So the toggle we selected of flight mode was this one. So if we move it, which is flight mode, if we move it down, we see that it does move down and up. So that corresponds to the correct thing. But at the moment, it just says we have one flight mode, which is obviously incorrect, as we want two. So to change this, we go to the flight mode switch settings. This will be at 1 by default, which is not what we want 2, so we change that to 2 and then hit save at the bottom right. So that's saved. Then we can go back to the RC input, and we can see here on the flight mode that it is now 2 modes. So as we flip between the two, we'll flip between the 2 modes. We've now set our 2 flight modes on our transmitter. And if we go to the flight mode switch setting tab, we can confirm this. So there's position 1 to 6 for our different flight modes, but in this case we're only going to have position 1 and 2. So if we flip our flight mode switch, you'll see it switches between position 1 and 2 on the screen. So that's great. These flight modes are called stabilize 1 and 2. And what this actually means, what these names actually means, is configured on the bottom half of the screen here, and we have different options for roll, pitch, yaw, and thrust, which I'll go through briefly now. We've chosen attitude mainly for the stabilized 1. This means that when you taking the roll, for an example, when you move your roll stick to the left and then release it, your drone will automatically level and stay where it is. So this is very easy to fly and great for beginners. For Stabilize 2, however, we've chosen Rate Trainer. Now, there are 2 options that are very similar to each other in the drop-down menu. There's Rate and Rate Trainer. Rate is where the stick offset from the neutral determines the rate of change on the control axis. But bringing the stick back to neutral stops the rotation, but doesn't return the airframe back to level. So this is where it's different from Attitude. But we haven't chosen rate here because that's a bit too difficult. We've chosen Rate Trainer, and this simply limits the bank angle, and so it's it's easy to fly with, better for beginners. And so there we have it. Don't worry if you haven't followed all this exactly, as you can get to grips with it in your own time if you want to. But you'll just need to trust us on this. That is the best option for you. And so at this point, we're nearly done with our configuration, and we just need to sort out the issue of the flight controller being mounted at a 90-degree angle. Now, to do this, we go on the Flight Data tab, where you'll see this artificial horizon, which should correspond to our movements, our real-life movements. But as you see, as we tilt it forward, the artificial horizon actually goes to the side. And this means that obviously our flight control board is mounted at a 90-degree angle to what the software thinks it is. And so we need to fix it. So we go to the Configuration tab at the bottom here to do that. And then on the side, we go to the attitude setting. And the axis which is incorrectly mounted, if you will, is the yaw axis. So we just need to change this to 90 to correct the issue. We save that at the bottom, right? And then we go back to the flight data just to check that that is now all correct. And as we tilt our ZMR250 forward, the artificial horizon now should go up, and it does. Excellent. And same to the left, right. And so that is all correct now. And so that's it. We've configured the CC3D flight controller for our ZMR250, and we've configured the transmitter, so we're all ready to fly after we've attached the propellers. If you do have any questions, please post them on dronecrest.com, where we'll answer them as soon as possible. Thanks again for watching.